So page 129 has sort of a different slant on things, but again, I want to emphasize that it's all about the conversion factors and it's all about the units. You let the units guide you through. The only thing new in the stoichiometry chapter is the fact that we connect moles to moles using the balanced equation. Everything else is basically the same stuff we've been dealing with. So this one, they give us a really nice equation because this is 1 to 2 to 1 to 1 to 1, so our molar conversion is going to be pretty simple. The numbers are basic there. But what they've done is bring in molar concentration. So molar concentration, the little brackets, moles per liter, right? So they give us that we have 0.750 grams of calcium carbonate, and basically that's a tablet of Tums. Again, extra information no one really cares about, but they're trying to put it in context for you. And then they tell us that your stomach acid has a molarity of approximately 0.001 moles per liter of hydrochloric acid. And how many liters is that it would neutralize? So the first thing that you probably will get hung up on is, oh my God, what do I do with this? Well, let's change the big M to what it really means, and then you'll see. So the big M is just moles per liter. So pretty much what it is another conversion factor. So they're not giving you another piece of information that you have to work in somehow on a side road or whatever. They're giving you part of the main channel of the work, which is just a conversion factor. So we do the same thing that we normally would. We start with the one that they gave us that isn't a conversion factor. Set up 0.750 grams of calcium carbonate, and then we just follow along as usual. We don't want grams of calcium carbonate, we want moles, which means that we're going to go calcium, carbon, 8. Calcium gives us, See, now this is where, if you guys were here, I'd be like, quick, what's the mass of calcium? And you'd be like, it's 40. Yay! Good job, kids. And carbon's 12 and oxygen's 16, but 3 is 48. So this whole thing is going to give us, oh really? It's fun, 100. 100 grams per mole. Am I wrong? It seems too neat and tidy, but it is. Okay, so then we're going to go put the grams on the bottom, calcium carbonate here, and the moles on the top. 1 mole of calcium carbonate is 100 grams. Perfect. So that's going to get rid of the grams of calcium carbonate, which means now I want to get rid of the moles. And I'm just going to, I can't quite bring myself to simplify it. Moles of calcium carbonate compared to moles of HCl. So we go HCl, and that's moles of that. Then I go 2 moles of HCl. For 1 mole of calcium carbonate. Great. Now I need to get rid of moles of HCl and end up with liters of HCl. Let's change that a little. What do I have that links moles and liters of HCl? Oh, there you go. That's how the moles per liter works. It just fits right in there because now I know that I have 0.001 moles per 1 liter of HCl. So it's self-explanatory when you look at it through the viewpoint of where are the units taking me. Then you don't have to try to memorize the steps or anything, you just follow the units. Now we watch to make sure our units are correct. Grams of CaCO3, moles of these guys, left with liters hydrochloric acid, and bam. Now we just run the numbers. And when you run the numbers, you should find, back on page, wasting your time. $15 liters. Now I'm just going to do this in my head real quick.